Hi, it's Mr. Sarisa, and today we'll do the application problem using a whispering gallery. So a whispering gallery is a room that's in the shape of an ellipse or elliptoid, half an ellipse really, because there's a floor going right through the center. And then, so if somebody's standing at the focus, right in the middle there, what happens is that anything they say hits the wall and bounces back at the other focus. And so you could whisper way over here on one person, and the other person's going to hear. So every sound bounces off the walls and the ceilings, everywhere, and it just focuses right back at the other focus. And so all this is an elliptoid. Um, and so it follows the same rules where you have the focus, the vertices, you have a center in the middle. And this works with the light as well. It's pretty cool. If you just flash the light anywhere in on the ceilings or walls, it'll bounce right to the other focus. So when you're solving these problems, it's so much easier to set up your own diagram and just to follow the rules, picture what's going on. I know I say this all the time, but it really is important. If you can visualize what's going on, you'll be able to solve the problem just by thinking it through. And most of the time, these problems aren't that challenging as long as you can make a picture of it. So I'm going to do, this is number 72 in the book, and we'll just go through that. So they have Jim sitting at one focus of a whispering gallery. So let me set this whispering gallery up, and then here's Jim sitting at one of the foci. And so he has a friend over at the other one. And they say Jim is 6 feet from the nearest wall. So here's 6 feet from that nearest wall. And his friend is 100 feet away. So I'm going to make him 100 feet away. What is the length of the whispering gallery? So that's pretty easy, because if Jim's 6 feet from the wall, then his friend's going to be 6 feet from the wall. So you just add up the length, and then for A, it's 112 feet. So I did that without having to have very much information. And most of them should be okay like that. And then they follow it up with another question: how high is the elliptical ceiling? Alright, so the center is right here. We want to know how high that is for B, right? If you think of these in the letters, A will be all the way to here, and C will be just to where Jim is, and then B is as high as it gets. So let's break this down. A, we can figure out, well, the 100 is split in half, so really that's 50 and 50. Right, so A is going to be 56, C will be 50, that's what I just found, and then B is just going to be that square root of A squared minus C squared. So square root of 56 squared minus 50 squared, and then luckily I have a calculator, and I work that out, and I get B is 25.2, and that's the height of the gallery. Just look at the picture, and it's 25.2 feet high. Okay, so again, nothing tricky with the application problems. The only thing I would make sure that you do is when you set these up, if you always put that origin on the center, that'll make things a whole lot easier when you're trying to solve them. Because then you can just use the x squared over a squared plus y squared over b squared equals 1 format. Okay, thank you. I hope this helped.